morning, everyone. Welcome to the hangover slot. I promise I'll go easy on all of you. My name is Hinton. You can follow me on Twitter and GitHub at noobcat. If you want to know what my username means, you can come and find me after this. I'm a front-end developer at Kickstarter in New York City, which we'll be talking about a little later on. I'm also a member of the Node.js hardware working group, so really enjoyed Rachel's talk yesterday. She was talking about the NodeBots community, so we're both part of that. We both also like cats a lot, which you'll also find out with this talk. I'm recently a member of the newly minted Ember Accessibility Project community team. So we work on trying to bring better accessibility to the Ember.js front-end framework. So again, talk to me if you'd like to know more about that. We're actively working on that. So why are we here? You're probably reading the abstract and wondering about that. Well, I'm going to try and keep things a mystery for a little bit longer. But the main points are that today we're talking about data and art and how they can fit together. We're also talking about making a mess. I think it's really important to make a mess, and I'll touch on that a little later on too. There's also a lot of feelings, so if anyone's seen my talks before, you know that this is coming, but I thought I would have a warning that there are a lot of feelings in this, but it's a good thing. So story time. I want to tell you a little story. In 1994, I was 9 years old, and I was reading the following book. This was my introduction to programming, and you're thinking 1994, pretty sure Windows 95 was about to come out, but this was my computer. So I was really, really excited to learn how to make art on the computer. I'd been drawing like my entire life, and I never really got that great at it, but as a kid, that's all I wanted to do with computers was I didn't want to type on them, I wanted to make art. So I was reading this book, and this was my introduction to programming. And so I guess you could call me the littlest artist at the time. But of course, I did grow up, and I still was in love with the idea of sort of the primitive things that go on behind graphics. And so recently I wrote a library called OLED.js, and its job is to put pictures on this primitive screen. So you can kind of see how that influence is still carried through. I'm not going to tell you how many years later and give away my age. So I think of myself as the accidental programmer. I didn't realize I was going to be a professional programmer when I was 9 years old. I was just having a lot of fun. And so in my personal time, I still like to emphasize on that, which is why I call myself the accidental programmer. I don't care about whether you use semicolons in your code or not. It doesn't matter to me. That's not what excites me about programming. So now I'm going to tell you a story within a story. I had a good friend, Lindsay Smith, give me this book, and he said to me, I think you'll really like it. And I think this was about 7 or 8 years ago. So for those who haven't read it, it's called Contact by Carl Sagan, by this lovely gentleman here. And the main character is a scientist called Dr. Ellie Arroway, and she works for the SETI movement trying to find extraterrestrial life. So she heads up the program at one of the astronomy towers. And so her job is to scan all of the signals in the sky and figure out whether or not that's an extraterrestrial signal. She has to dig within the noise and try and find that signal in there. And she actually does one day, and her team finds a message from outer space. And so this ends up taking her to New York City, where she has to attend a lot of like really big meetings with the government and with security agencies and with scientists all over the world. And it was the first time she'd been to New York City, and she fell in love with it. And when I read this book initially, I was in Australia, and when I moved to New York City, I felt the same way, and I almost carried her in my heart while I did. And so she had to take the subway in order to get to a lot of her meetings. And it turned out that as she's riding the subway, because her mind was so tuned over the last few months to listening for signals within the noise, that as she was on the train, she ended up missing all of her meetings because she was listening so intently for secret messages that she didn't realize, what was real and what wasn't anymore. And so I found myself, when I first started taking the subway, trying to listen for messages in that too. But then I realized something about the difference between myself and Dr. Ellie Arroway, and that is that I kind of look for this sort of stuff too, which is how we're similar, But Dr. Arroway didn't have JavaScript. So what if Dr. Arroway did have JavaScript? You know, how could she try and visualize the hidden messages in the sort of noises that she falls in love with? So I found myself asking, what does sound look like? And you know, how can we visualize that? So we saw some of that last night, where the sounds were visualized along like the frequency samples. I'm going to do something slightly different today. And we're going to find out via art what sound can be made to look like. So we're going to use the Web Audio API. And before I go into this, you're probably wondering what the Formulartic spectrum is. But that's a made-up word, so I'll explain. So when you work with data, especially in your professional job, you want to make sure that the integrity of that data is accurate, and the way that you're presenting that data is also super accurate. And so when you're creating art, being loyal to the data is really important in order to create beauty that people can still relate back to the data, right? So that's really, really important. When you start getting on the data corruption side, things start to get messy. There's a slight disconnect, and you're not really sure what's going on. But the thing is, like, that's art too. Like, who cares? It's not important, because you start with something and you come up with something unexpected at the other end. So the talk today is sort of focusing more towards this messy side, just to give you a bit of an indication. So the way that I wanted to use the Web Audio API was I wanted to record samples of the subway, and then I wanted to analyze that PCM data. So what is PCM? It stands for pulse code modulation. So it's actually the raw, uncompressed audio data. So it's the samples that have been taken from the analog world and then digitized. So each value in like a PCM file, the sample ranges from -1 to +1 in value. So that's really important, because we're sort of going to map to that later. And some common PCM format file extensions are WAV files, AV files, .au, .l16, and of course .pcm. And this is a rather wonky photo I took from Wikipedia that sort of shows how you have your analog sine waves, and then you do math to figure out like how to actually sample that at regular intervals. So they're the sort of values that we'll be playing with. Now, I spent a lot of time sort of secretly trying to record sounds on the subway, and I decided to pick a really annoying, obnoxious sound that we've all sort of learned to ignore. So if you've never been on the New York City subway before, you may not be familiar with this, so I'll play it for you. Those who have will be very annoyingly aware of it.
Stand clear of the closing doors, please.
And that ding-dong at the end every time. Okay. So what if we took this sound, right? What if we took it as a WAV file and opened it and looked at the data? And what if we took all of those values from -1 to +1, and we said, okay, each sample is a pixel on our screen. And then what if we took that range and just mapped it over so it would be 0 to 255 to make it easier for us to work with, right? -1 to +1 is a really weird range to work with, unless you're working with random numbers. And what if that new value that we've mapped it to would affect the hue of the pixel that we're putting on the page? So I won't freak you all out with too much code this morning, given that we were all drinking the night before, but it takes 12 to 13 lines of code in order to achieve this. A lot of art is just a bunch of for loops, and I was telling someone this last night. You're just taking data and then looping around and doing crazy things with it within the loop. So we use the audio context to decode the audio data, and we're just feeding in like what's it called, an array buffer. And then once we've decoded that, within the promise, we can get one of the channels. So we're just getting the left ear, because it's art. It doesn't matter if we're dropping the right ear. We loop through that, and once we've mapped the value from 0 to 255, we can then generate a pixel out of it by generating a hue, saturation, luminosity, converting it to RGB, and then we can manipulate a image data canvas object, and then put that back onto the canvas in that very last line. So these slides will be up online later, so you can have a look at that more closely if you like. So what does it look like if we just do this? Well, this is sort of what we have. And so that comes out really interesting. I actually thought it was really beautiful. And so there's a lot of pixels in there. But you can sort of see this rainbow banding effect, which I think is really, really cool. And if you've really been paying attention to this photo in the last 10 seconds, you'll realize that you can actually see the patterns of the sound. And this really delighted me a lot. You can actually make out the individual words through those bands at the top. So you can actually figure out, based on how big the bands are, which word and syllable the speaker was saying. Then you can see this big empty bit, that's the white noise. And then the very obnoxious ding-dong at the end is in like vibrant rainbow colors. And I thought this was actually really cool. Like, this was proof that the data integrity is like one for one. You can actually see it. And so that's really cool to verify that you've brought that in and visualized it. There's only one problem with that. That picture that you just looked at is 300,000 pixels. And a couple of times I got the code wrong and I just completely crashed the browser because it got stuck trying to work on something. You can't console log within that loop or it will freeze, for example. And when you think about it, I just got the one channel, I didn't get the other ear. So imagine if you had that, it would be 600,000. So it's a lot to work with, and it's a little bit scary. So this is a bit of a problem. Like, how do we sort of like reduce that? I thought maybe the best way to reduce that is to map audio to visuals and then back out to audio again. What if we can make different audio out of this? So what if we took the simple concepts of a song, right? It's 16 beats. So how do we sort of divide that up? Well, theoretically, we could take the 308,728 samples, and we could divide that by 16 beats, right? So now we have our chunks of samples to do something with. But that's still a lot of samples. That's 19,000 samples. So what if we sort of start getting real with the data corruption and start losing data? And what if we average the sample values of each beat? So essentially, we add all of them together, divide it by 19,000, and then we end up with a -1 to +1 range like value for every single beat. Then we can take that value and do something sort of meaningful with it, but it's a lot simpler to work with. So what if we wanted to put people back on the train again? We might be able to designate the seat color of each beat based on the value. And maybe that seat color denotes what drum beat or what oscillator note we're going to play. And then this little kitty at the bottom, what if he was sitting on a seat that was designated by a specific value as well within that range? What if he could do a guitar strum and a note to sort of accompany that? So what we get is something like this. So there are 8 seats on the left and 8 seats on the right, so that makes up 16 beats. And you can see here the cat has appeared in this sort of pattern. Now this is taking the direct data from the PCM values, again from that stand clear of the closing doors please sound. So without further ado, let's have a listen to what that sounds like. Okay, so you get the point. Not sure whether that's... Thank you. So that's very strange music. And I sort of thought, what if we could make this a little more entertaining? So I have a friend, and his name is Mark Johnson. And you can tell he lives in New York just by looking at him, can't you? And he's a very incredibly talented designer, and he's also just a really funny guy. So I met up with him in a cafe a couple of weeks ago, and I said, you don't happen to have any silly sample sounds that you've recorded of your own voice, do you? And without surprise, he said, actually, I do. And he just Dropboxed me a bunch of samples. So what happens if we put Mark into this train? What is this going to sound like? Let's have a listen. I think the sound's a little muffled. Anyway, that's sort of a little bit funnier. And he hasn't seen this yet, so I guess I'll just send him this video. Okay, so a little bit about how I put this piece of art together. Most of it is SVG images that I've drawn in a different program and imported them in just as image tags. It's a lot of divs, so those seats are just floating divs next to each other, right? So this sort of application is way easier to deal with than Canvas in my last example, because you're just working with CSS and you're working with JavaScript manipulating those DOM elements. So I highly recommend doing art with divs and things like that, because you probably couldn't tell by looking at it that it was just straight markup that you can look at in the Chrome developer tools. And then I'm using CSS animations for that cursor to move across. And I'm also doing CSS animations, the cats kind of dance along with their strum as well. And yeah, obviously I'm not a musician because that didn't sound great, but I'm hoping to sort of improve this music, and I've been talking to some of my musical colleagues and they've been helping me out. But I'm better at hardware things, and I think I'm better known for that. So I thought, okay, what would playing this music look like in the real world? Like, can I do something to do with hardware that can transfer this really weird composition in the browser, and then we can play it back out in the real world again? So I attend this meetup in New York City called JavaScript, called Brooklyn.js, and they have this really funny riff on the MTA Metro card that you use in the train system. So it just says Brooklyn JavaScript. This is what the actual card looks like. So you can see it's actually really clever, and that's our ticket to get in, and it's also our drink ticket to get a free drink, or you can keep it and you have a souvenir. And I thought to myself, that's such a clever riff to do on it. Like, could I do my own riff? So I decided to lay out a custom printed circuit board, and I thought, what if I put a speaker on this circuit board and then we can play the sound? But making it look like a Metro card sort of makes it obvious what sort of sounds it's going to play in the first place, so that's the tie back. So this is what it looks like. I think if they turn the video on, I actually have it here. So if you wanted to come and find me later on, that's it there with the giant megaphone. So this is like a little 3D printed house for a speaker that I stole from a musical greeting card. And you can program the chip on the board as well using the headers in the corner here. And it just plays music off an SD card. So if you can put that composition on an SD card, it will work. And I think it'll be a little too quiet for me to... I don't think you can hear it, but come and find me later. So here's a quick video of me testing it out for the first time after I'd soldered it all together. I don't think you can hear it. I'm sorry, the audio's gone. But you hold the button down and it plays the sound while the button's held down. So this is also using an 18 mega 328p. So if you've ever played with an Arduino before, I actually just ripped the microcontroller off the Arduino and then just put my own custom code on it. So you know, this isn't quite finished yet, and I feel like there's not enough JavaScript in it for me to say it's a JavaScript project. So I actually wrote something last year called AVR Girl, which uses Node.js to flash compiled programs onto microelectronics. So I've actually already done that. So I did write the program that runs on this in C++, but it uses JavaScript to flash it on there, so that's pretty cool. The next thing I want to do is to stream the resulting song over a USB connection with Node.js using WebSockets, and it will stream it over to the SD card and save it as a file. So I started working on that a couple of nights ago during the conference, and I'm sort of almost there, but I have some weird SPI bottleneck issues, so I will blog about that soon if I manage to get it up and going. And of course, I want to make better music, you know. Not very good at it, but we'll figure it out. Okay. So things got a little bit weird. But you know, it's art. This is the point. This is what I'm trying to tell you. You don't always have to use your code for professional use. You know, when I work in my job every day, I want my code to look perfect. I want it to be readable. I want it to be performant. But whenever I go home for the day, I almost want to rebel against that and be the little girl with the Commodore 64 again. And so this is why I'm up here today, because I want to go over what was the point of this. So creative coding gets you out of your comfort zone. When you're not used to using divs for things like music and moving cursors and things like that, it teaches you how to think about the tools you use every day in a different way and how you can sort of exploit that kind of thing. Art doesn't care about your semicolon feelings. So if you create really messy code with unused variables and missing stuff all over the place and lots of repeated sort of copied and pasted functions, art doesn't care. It's still going to show you what you wanted to look at in the end. And so you can really have a play, ignore the actual code, and just expressively start writing. Because art doesn't care about perfection. It's about exploration. So KillMC, or Killian McMahon, he's a colleague and very close friend of mine. And one day during a hackathon at work, I said, can you just teach me about music? And so this is him attempting to teach me about chords, like G major and C major. And he also taught me about like staying within those chords and creating really cool sort of repeated loops. So I'm really hoping to apply that new knowledge to this music and help it evolve. But I've never worked with Killian in this way before. He's a designer and he writes the HTML and CSS, and then I write the JavaScript that accompanies his work. And that's how we normally collaborate. But this offered this new sort of collaboration, given that he plays amazing music outside of work. And if anyone's going to PyCon this year in Portland, he's actually going to be opening and in a band playing. And it's a really awesome band. They're called the Adventure, what are they called? The Venture Capitalists. And they make fun of the startup scene. And they're really, really cool. So definitely check them out. So I guess what I'm saying is that art is about what you learned. It's not about the normal things that we care about when we talk about syntax. So take some time, if you have the privilege of spare time, and write some messy code and make lots of mistakes and don't necessarily go back and fix them. You deserve a break from being judged. We're always writing on each other's code reviews and we're always like painstakingly going over line by line of code. But what if you could just type like this? It feels so freeing, it feels expressive. You're just throwing stuff out there to see what happens. I had no idea that a train with cats sitting on it playing guitars was going to come out of this project, but that's what happened. So code like no one's watching. I want you to all remember that. Code like no one's watching. And if you can, don't get rebase before you push it up. So I'm starting to see an alarming problem in our industry where juniors look up to programmers who are mid-level and senior and lead, and they see us writing this perfect code out of the gate because they see it after we've opened the pull request. Or they join a company and they look at our finished code that's already sitting in production. And I see juniors, even in my job, just frozen looking at this empty text file when they're starting a feature. And it's that fear of the blank canvas. They think that they have to write everything perfectly and have all the details in their head the first time. And that's just not true. That's not how any of us write, I don't think. We write something sort of good, and then we write it gooder, and then we write it the goodest, right? That's how it works. And having to explain that and having to get those juniors to come and pair with me whenever I've started something so they can see my process, that shouldn't be necessary. We should be showing people history, even in our Git, so they can see that we wrote something messy and then we went back and we thought about it and we changed it in ways that we wouldn't have seen when we first started. So just git push. And the scariest thing I've ever done last night was I pushed all of the art that I showed you today, I pushed it all up to GitHub, and I left it alone. There's multiple audio contexts going on, and they all have slightly different ways of naming the variables, and it's a complete mess, but I'm inviting you to look at it so you can see how stuff evolved. And it doesn't matter, because all I wanted people to see was the final product, and it works perfectly fine. So think about that in your everyday, so that we can all be learning more off each other and not being so terrified of having to be perfect the first time, so that we can make it okay for others. So if you take anything away today, I want you to make some art. I want you to just throw it away if you don't like it, because it's just code. You can write more. So if you'd like to have a look at my art examples, you can go to that address, and the repo will also go there so that you can have a look at the code if you like. TSW just stands for I love the subway. That's my secret. I ride the subway even when I'm not going anywhere sometimes because I love it. So I was trying to make everyone else love the subway today. And if you'd like to go through my slides again to look at some of the code samples or just like play with the stuff that I showed, you can go to, again, nukecat.github.io/Formulartic Spectrum. I just got a Jekyll build error in my email, so I will try and fix it. It's not quite up yet. And I will be blogging about this project really soon to show how I made the electronics and sort of why I wanted to do this weirdo thing in the first place. So keep an eye out for that. I'm a pretty regular blogger. And thank you.